Question number 13 is a straightforward question that is drawn from modern physics, and it says, see, in an experiment, electrons are accelerated from rest. So they are accelerated by applying a potential difference of 500 volt. You need to calculate the radius of the path if the magnetic field is then applied. So what has essentially happened is the potential difference has accelerated the charged particle, thereby increasing its speed, and that charge is now in the magnetic field. So we need to calculate the radius. So this time this is going to be R equals to mv by bq. Well, mv is the momentum, and that can be written as 2km by bq, and the kinetic energy, that's root of 2qvm upon bq. That's all. Nothing more than that. You put the value of all those parameters and you would get 7.5 into 10 raised to the power minus 4 as the radius, thereby making option number 4 as the correct option for question number 13. All right, let's move ahead for the next question now. Question number 14 is something like this. An equilateral triangle ABC is cut from a thin solid sheet of wood. So let me try to show you the figure, and it goes something like this. Okay, so there's a solid sheet of wood and an equilateral triangle has been made here. So you may first see the figure, then we can see. So this is the given equilateral triangle ABC, and it is made from a solid sheet of wood. That means it is not 3 rods making a frame, it's an entire plate. You need to understand that particular thing. Okay, now let's see. D, E, F are the midpoints, so that's very clear, and G is the center of the triangle. The moment of inertia of the triangle about an axis passing through G and perpendicular is I naught. If the similar triangle DEF, so it's something like this. Let me show it with the help of figure here. So here is a triangular sheet, and there is a point which is G. The moment of inertia about an axis passing through G and perpendicular is I naught. Now it says, if the similar triangle DEF is removed, now what we have done is that taking the mid, this part, the yellow part has been removed. So there would be a vacant, hollow portion, a triangular vacant, and this would be remaining. We need to calculate the moment of inertia of the remaining part, and that is in terms of I. So essentially the question is, first there was a complete triangular sheet, moment of inertia was I naught. Then from the midpoint, this yellow part has been removed, and we need to calculate the moment of inertia of the remaining portion. Well, it goes in a bit of tricky way, and it's something like this, say. Initially, the moment of inertia was I naught passing through this, the centroid, but yes, the axis is perpendicular. So one thing I can do is that just by going through a dimensional approach, I naught is a constant k, it's not radius of gyration, a simple constant multiplied by ml square, because we know that's m multiplied by distance square. Dimensionally, there would be the case, and a factor would come. Like when you have a sphere, 2 by 5 mr square. When you have a hollow sphere, 2 by 3 mr square. So following the same technique. And now, what has been removed is this. So let me call the moment of inertia of a triangular plate of the shaded one, let me call this as I1. Well, by symmetry, the factor is going to be same, but the mass would be 1/4, because that can be divided into 4 parts, and the length is of course L by 2 whole square. So this is the moment of inertia of this central triangular plate, which is shaded for the sake of your simplicity. And now I need to calculate the moment of inertia of the remaining one, so that the question calls it as I. So that's very straightforward. That will be I naught minus of I1. And when you solve this in a very straightforward manner, the value is going to be 15 by 16 times I naught. So yes, the correct option will be option number 2. Now it's time to move to the next question. Question number 15 from kinematics, and you would see the question is related to radius of curvature in a projectile motion. So let's see, and this requires a bit of calculation. Okay, so here it says a body is projected at t equals to 0 with a velocity of 10 meter per second at an angle of 60 degree with the horizontal, and the radius of curvature at 1 second is r, and neglecting air resistance, taking acceleration due to gravity g as this much, we need to calculate the value of radius of curvature. Fine. So in order to calculate this, what we will see is that you see that initially the velocity is there, which is 10 meter per second at an angle of 60 degree. So the x component of the velocity will be 5 meter per second. In other words, the x component of the velocity at 1 second would still be 5 meter per second for simple good reason that x component of velocity does not change. How about the y component of the velocity? Well, y component of the velocity is the initial y component, which is 10 sine 60, that comes out to be 5 root 3, plus at. So acceleration being minus 10, t being 1. And this thing now will be 10 minus 5 root 3 because overall it's coming out to be negative. So indicating that after 1 second, the particle is in the descending phase. That's not a problem. Okay, so here's the situation now. This is the x component of the velocity. This is the y component of the velocity. And one can easily calculate the resultant velocity. And that resultant velocity is, of course, under root vx square plus vy square. Even calculating this angle is not a problem now. By all possible way, tan theta is vx by vy. And once you get the value of tan theta, you can easily find the value of sine theta and other stuffs. So let me call this particular angle as theta. All right, and v would be under root of vx square plus vy square. And we know that the acceleration due to gravity is in this direction. Now it's so clear, while you require to calculate the radius of curvature, then we resolve the acceleration into velocity and perpendicular to the velocity. So the normal acceleration is going to be g sine theta. So therefore, as per the standard formula, radius of curvature would be v square divided by g sine theta. Now yes, a bit of calculation is required, but this is all when it comes to the conceptual part. You calculate it, you would get 2.8 meter as the correct one. So therefore, the correct option for this is going to be option number 3. Now, it's time to move to question number 16.